So guys, as I said, we want to calculate the reactant unit, the amount of the product you make. So this chapter is about calculation. What do we need for calculation? We need a balanced chemical equation. So we know the ratio between reacting substances. Once we have a balanced equation, we can convert grams to moles and moles to moles and moles to grams. So what is mass relationship in a chemical reaction? What do we do in chemical reaction? We look at the atoms and molecules, then we look at products, which is in grams or kilograms or tons. So we mass relate micro work, which happens at atoms and molecule level, to real mountains of product. And we show you, and you already know how to do that. I'm just reviewing. So if I'm dealing with atoms and molecules, then I will use atomic mass. What is the mass of atoms? How do we define mass of hydrogen atom? What's mass of one hydrogen atom? What's mass of carbon? What's mass of lithium? What is the unit of mass? Because atoms are really, really small, the mass is really, really small, we use a unit which is called atomic mass unit. So if I want to tell you mass of hydrogen, I use atomic mass unit. It's a teeny weeny fraction of gram. You want to measure mass of an atom? It's right in here, I think. We use atomic mass unit. What's the definition of atomic mass unit? Well, atomic mass unit is defined to be 1/12 of mass of one carbon atom, or 1 carbon 12 atom is defined to have 12 atomic mass units by definition. If you use this scale, hydrogen 1 atom is 1.008 atomic mass unit, almost 1 atomic mass unit. Oxygen 16 atom, 1 oxygen 16 atom is 16 atomic mass unit, 16.00 atomic mass unit. I have a number which is explaining atomic mass unit. I don't know if you can see it here, but it's, let's see if I can't even open it. Well, you can look it up and I might be able to show you in our calculation. It's 10 to the power of 24. It's a number times, it's 1 point something something times 10 to the power of negative 24 grams, extremely small fraction of a gram. All right. So we can say, I want to remind you of something else that you learned in Chem 2A. Remember, we said all elements have at least 2 isotopes. What are isotopes? If I say carbon 12 and carbon 13 are 2 different isotopes of carbon, they are both having atomic number of 6. That means they have 6 protons. 6 protons. How many electrons? Same number of protons. How many neutrons? The difference between mass number, this is mass number. The difference between mass number and atomic number shows number of neutrons. Why? Because mass number, you may remember, it was protons and neutrons, number of protons and neutrons. Atomic number is only number of protons. So if I subtract 6 from 12, I get 6. This is number of neutrons in this case, and number of protons here. Atomic number 6, 6 protons. How many electrons? Same number as number of protons. How many neutrons? 13 minus 6 gives you 7, 7 neutrons. So do you see? Do you see the difference between carbon 12 and carbon 13 is only 1 neutron. So why do we call this isotope? What are isotopes? Different atoms of the same element, which are only different by their number of neutrons. So if I have a mixture of these two, what is the mass? What is the mass of carbon 12? We said 12 AMU. Why? Because it has got 6 neutrons and 6 protons. Mass of 1 proton is almost the same as mass of 1 neutron. It's almost the same as 1 AMU. So 12 AMU in this case. Here, the mass is 13 atomic mass unit because you have got 7 neutrons and 6 protons. Each one of these, 1 AMU, add them together, you get 13 AMU. So if we want to get the mass of a mixture of these two, does it make sense? The mass is neither 12, neither 13, it's somewhere in between. But how can I calculate weighted average? How do I do that? If I had equal mixture of carbon 12, 50% carbon 12, 50% of carbon 13, I will add them together. 12 plus 13 divided by 2. 12.5 would have been mass, average mass of an average carbon. But I have a lot of carbon 12, very tiny amount of carbon 13. So if I want to get the weighted average, the answer must be closer to this one. How do I do that? I get the percentage. This is the percentage of each one times their mass, percentage of the other one, times their mass, you get average mass, and we did some of this in Chem 2A. If that doesn't make sense to you, please come to see me during the lab help time or during office hour. I would love to explain this to you person to person, face to face. It makes more sense. All right. So guys, if I am going to show you just one cell, I'm showing carbon. Let's ignore this one. If I want to look at carbon that I showed you, I have one location in periodic table to show the carbon. I have one number to show, which is mass of one atom of carbon, except carbon is neither 12, neither 13. The mass is somewhere in between. So can I say, I did use the percentage of abundance of isotopes, as I did on previous page. This is the number which comes here. It shows the average mass of an average atom of carbon. So periodic table cannot show different masses of different isotopes because it has one location for each element, but it will show you the average mass of an average atom. Ignore this for a moment. I'll get back to you on this. So natural lithium is a mixture of these two isotopes, lithium-6 and lithium-7. And mass of lithium-6 is 6.015 atomic mass unit. Because I said neutrons and protons are almost 1 atomic mass unit. That's why you have a fractional number. That's why you have decimal places here. And then 92.58% of the lithium metal is lithium-7. Lithium-7 has this mass. By the way, we can measure mass of one atom using atomic mass spectroscopy. It's called mass spectroscopy. It's $100,000 machine. We have it at Shasta College. When you take organic chemistry, you get to work with it. We can also measure the percentage of abundance of each isotope by mass spectrometer. That's where the measurement is coming from. So if I'm going to calculate average atomic mass of lithium, how do I do it? I must use abundance and mass of each isotope. So abundance 7.42% times the mass, which is right here. Abundance of lithium-7, 92.58 times the mass. And if I add the top of this ratio, what do you get if you add 92.58 to 7.42? You get 100. That means you have 100 atoms with this total mass, as total mass in AMU of 100 atoms of lithium. And then if I divide it by 100, I get average mass of an average atom of lithium. So that's how I'm going to calculate atomic mass for lithium. That's where these numbers are coming in the periodic table. 6.94 atomic mass unit. And it is convertible to grams because you know atomic mass unit is certain number of grams. So if I go to the periodic table, I have lithium here. If I try to write mass of an average atom of lithium, 6.941, that's where it's coming from. It's an average mass of all the different isotopes in the mixture based on their abundance.